Hello, everyone. Space exploration represents one of the most extraordinary and ambitious undertakings in human history. The desire to reach beyond our planet, to explore the unknown, is deeply embedded in our nature. This journey, which began in the mid-20th century, has led to some of the most significant achievements in science and technology, reshaping our understanding of the universe and our place within it. The story of space exploration starts with the dawn of the space age in the late 1950s. It was a time marked by intense competition between the United States and the Soviet Union, two superpowers locked in a Cold War. The launch of Sputnik 1 by the Soviet Union on October 4, 1957, marked the world's first artificial satellite, orbiting Earth and sending back radio pulses. This event sent shockwaves around the globe, signaling the beginning of a new era. For the first time, humanity had sent something beyond our atmosphere, a small, beeping object that represented the limitless potential of space exploration. The success of Sputnik ignited what became known as the space race, a period of rapid technological development and fierce competition between the US and the Soviet Union. The Soviets continued to lead with another historic achievement on April 12, 1961, when Yuri Gagarin became the first human to orbit the Earth aboard Vostok 1. His single orbit around the planet was a monumental achievement, making Gagarin an international hero and proving that humans could survive the harsh conditions of space. In response, the United States ramped up its space program, culminating in President John F. Kennedy's bold declaration in 1961 that the U.S. would land a man on the moon before the decade was out. This ambitious goal led to the Apollo program, a series of missions designed to achieve this monumental task. The Apollo program stands as one of the most significant achievements in the history of space exploration. After years of intense research, development, and testing, on July 20, 1969, Apollo 11 successfully landed the first humans on the moon. Neil Armstrong's iconic words, "That's one small step for man, one giant leap for mankind," echoed around the world as he became the first person to set foot on another celestial body. This momentous event was not just a triumph for the United States. It was a milestone for all humanity, symbolizing what can be achieved when we push the boundaries of what is possible. The Apollo missions continued, each one building on the successes and lessons of the last. By the time Apollo 17, the final mission, concluded in December 1972, 12 astronauts had walked on the moon. These missions provided invaluable scientific data, from the analysis of lunar soil and rocks to a better understanding of the moon's geology. The knowledge gained from these missions continues to inform our understanding of planetary science today. While the moon landings were the most visible achievements of the early space race, other missions also made significant contributions to our knowledge of space. The Soviet Union, for instance, was the first to send a spacecraft, Luna 2, to impact the moon in 1959, and the first to land an uncrewed craft, Luna 9, on its surface in 1966. They also launched the first space station, Salyut 1, in 1971, paving the way for long-term human habitation in space. The end of the Apollo program marked a shift in space exploration. While the intense rivalry of the space race had driven rapid progress, the focus began to shift toward international cooperation and the development of space infrastructure. The U.S. launched the Space Shuttle program in 1981, a new era in spaceflight that introduced reusable spacecraft designed for various missions, including deploying satellites, conducting scientific research, and constructing the International Space Station, ISS. The ISS represents one of the most ambitious examples of international cooperation in space. Since its construction began in '98, the ISS has served as a laboratory, observatory, and factory in orbit, and a home for astronauts from around the world. The ISS is not just a symbol of what humanity can achieve when working together. It is also a critical platform for scientific research. Experiments conducted on the ISS have led to advancements in fields ranging from medicine to material science, as well as a better understanding of how long-term spaceflight affects the human body. As technology advanced, so did the scope of our space missions. Robotic spacecraft have played a crucial role in exploring the solar system. NASA's Voyager 1 and 2, launched in 1977, embarked on a grand tour of the outer planets, providing humanity with its first close-up images of Jupiter, Saturn, Uranus, and Neptune. These missions revealed the complex and diverse nature of our solar system's giant planets and their moons, expanding our understanding of these distant worlds. Mars, often called the Red Planet, has been a primary target for exploration. From the Viking missions in the 1970s to the more recent rovers like Curiosity and Perseverance, Mars has been a focal point in the search for signs of past life and understanding the planet's geology and climate. The Perseverance rover, which landed on Mars in February 2021, is part of a new wave of missions aimed at preparing for future human exploration. Equipped with advanced scientific instruments, Perseverance is searching for evidence of ancient microbial life and collecting samples that may one day be returned to Earth. Beyond Mars, robotic missions have ventured even further. The Cassini mission, which explored Saturn and its moons, revealed the stunning complexity of this gas giant system, including the discovery of hydrothermal activity on Enceladus, one of Saturn's moons, raising the possibility of a subsurface ocean that could potentially harbor life. The New Horizons mission gave us our first close-up look at Pluto in 2015, revealing a surprisingly complex and geologically active world. The desire to explore further has also driven advancements in space telescopes, which have allowed us to peer deeper into the universe than ever before. The Hubble Space Telescope, launched in 1990, has provided breathtaking images of distant galaxies, nebulae, and other celestial phenomena, revolutionizing our understanding of the cosmos. Hubble's observations have helped scientists determine the age of the universe, the rate of its expansion, and the existence of dark energy. Its successor, the James Webb Space Telescope, launched in 2021, promises to delve even deeper, potentially unlocking secrets about the formation of stars, galaxies, and even the origins of life itself. As we look to the future of space exploration, one of the most exciting prospects is the possibility of human missions to Mars. NASA, alongside international partners and private companies like SpaceX, is actively planning for crewed missions to the Red Planet. These missions would represent the next giant leap in human space exploration, involving complex challenges such as life support, radiation protection, and the development of sustainable habitats on another planet. A successful mission to Mars would be a monumental achievement, potentially paving the way for a future where humans live and work on multiple planets. Space exploration is not just about reaching new worlds, it's also about understanding and protecting our own. Satellite technology has revolutionized our ability to monitor Earth's environment, track weather patterns, and respond to natural disasters. Satellites play a critical role in communication, navigation, and scientific observation, providing data that is essential for understanding climate change, managing natural resources, and ensuring global security. The emergence of private companies in space exploration is another significant development. Companies like SpaceX, Blue Origin, and others are driving innovation and reducing the cost of access to space. SpaceX's development of the Falcon 9 and Starship rockets, with their focus on reusability, has dramatically lowered launch costs, opening up new possibilities for commercial space ventures. The growing role of the private sector in space exploration could accelerate the pace of innovation and lead to new opportunities in areas such as space tourism, asteroid mining, and even the establishment of lunar and Martian colonies. Space exploration is also inspiring a new generation of scientists, engineers, and dreamers. The excitement generated by missions like the Mars rovers, the images from the Hubble Space Telescope, and the progress of commercial spaceflight are encouraging young people around the world to pursue careers in STEM fields. These future explorers and innovators will be the ones to carry humanity's exploration of space to new heights. In conclusion, Space exploration is a testament to humanity's ingenuity, curiosity, and drive to explore the unknown. From the first satellites and manned missions to the moon, to the exploration of distant planets and beyond, our journey into space has fundamentally changed our understanding of the universe and our place within it. As we continue to push the boundaries of what is possible, the future of space exploration holds even greater promise, with the potential to unlock new discoveries, solve global challenges, and inspire generations to come. The story of space exploration is far from over. It is a story that is still being written, one that will continue to unfold as long as there are new frontiers to explore. Thanks for watching. Subscribe to the channel, like, comment, and share.